All right, welcome everyone. Today, I got just 15. We just had 14. Got another 15 signed up, and we're ready to go. So today was a project that I needed to do for myself. It was a Raspberry Pi project that I needed to create some items in a case for. I could have you know, probably machined and, plotted out and drew and made the actual case itself, which is this bottom section here. But it was like $10 or something like this for a nice aluminum case. One of the issues that I did have with this case, if anybody's familiar with the Raspberry Pi, I needed to get to the pins in some of the I/O to be able to add some buttons and switches and such too. The issue in the problem with this case is it did not have access to be able to get into it from the top side. It did kind of have a nice little method on the bottom side, but I needed to add it to the top. So to be able to do this, I needed to add a hole in the top of the Pi case. So the challenge with this is not really cutting the aluminum, although we'll talk a little bit about that. But it was more or less being able to accurately position this product on the table to be able to know where the machine is and know where it's going to cut. So the first thing that I started out and I did was drew and measured the case itself. Open up the spire here. So this is pretty much the case itself that is drawn, and I also added the hole of where I want it to be. Now you see slightly different than what is in the image that's actually cut. I needed to make it a little bit bigger, so we'll show how we went ahead and did that. So this was the actual case itself that I made and put in and located at 0, 0. No real reason for that, but to be able to place this on the job and get it centered and know how to get this put in place, the first thing that I did was opened up another version of Aspire. VCarve Pro works the same. I just happen to be using Aspire. Going to go ahead and create a new job, and we need to make could call it a template for this. So the size of it really doesn't matter. I'm going to go with a 12 by 12, and I am cutting it out of a HDPE plastic, which is 0.5 thick. I'm going to go to the machine bed since I'm cutting all the way through, and I would say okay. So this is the 12 by 12 board that we'll end up cutting a template into. So I'm going to go back over to where I have the actual case drawn. I've already, again, drew that. And I need to have and grab this outside edge. As a matter of fact, I'll just grab all of these vectors here. So I'm going to right click and copy. Come back into our new instance of Aspire. I'm going to right click and paste. And it does paste it into the same location as the bottom left. So I did this, and I actually ordered a couple more. So I did it one by one. We do have a video. I have 5 more of these to do. So we're going to lay these out in a pattern where I'll be able to do 5 of them at one time. So to do that, we're going to just simply drag this over and place it into the material. So what's going to happen is we're going to take and cut out the outer rectangle of this. We're going to use that, cut on the inside into our plastic. And that gives us a way to align it, place these in there and kind of sync the machine up to where we drew it. So first, since I am going to make multiples of this, I'm going to use the copy array. I'm going to go with 2 of them in the X and the 3 in the Y. Even though I only have 5, it's going to make a total of 6. That might be okay. I do want to add a little bit more space between those. So I'll just do a Control Z. Selecting all of this objects once more, and I'm going to go in with a spacing of 3/4. Maybe that might be too much. We'll find out. That's looking all right. So I did have the option for these to be grouped when I array copied those. Again, going into the array copy, we see group objects. And that just makes it a little bit easier when you go to array copy to come back in and select it, to be able to modify the placement of it without having to worry about grabbing all of it. I am going to later ungroup all of that. So I'm going to use the centering tools and just center it within the material and close. So now to be able to toolpath our template, I need to go in and ungroup this. So typing the letter U for ungroup. Then I'm only going to toolpath the objects are on the outside. So this outside edge of our case. And coming over to create the toolpaths, I'm going to use a profile toolpath, cutting on the inside to a depth of 0.51. I do want to cut all the way through. For the cutout pass, I'm going to use the 1/4" cutter. Select, add a ramp cut, and just call that temp for template. Then calculate, making sure that I have set the option to be on the inside. And I am also going to use a conventional cut. Cutting plastics, conventional is typically the best way to go. And once that is set, we'll select calculate. Getting a warning, we cut all the way through. Okay with that, just making sure that the numbers are right. Go ahead and preview what that looks like. All right, that's looking good. So that is the first step in creating this. Now, it may be the case that I cut some today. I want to be able to use this fixture again a week from now or a month from now, or I want to be able to use it again. So now we'd be challenged of how do I, once this is cut, pulling it off the table and putting it back on. I'll show how we do that in just a second. But before I do that, I'm going to jump over here to the video of it actually cutting. So I only cut one of them the first time, so it cut out. I did a test fit to make sure that it was going to go in there, and it was fairly tight. At that point, it would have given me a chance to come back in to VCarve Pro and model an allowance in there to have it cut just a little bit bigger. I honestly did this, cut this yesterday, and I can't remember if I actually had to make it bigger or not. It did slide in there, and I liked the way it fit. It kept in there snug and stayed fairly tight, so that was good. So once that was done, that allowed me, oh, there it is. I did do a second cut on it. And there, it fits in there a little bit better, fits in there snug and tight. So that is the first step of what we're just doing here now, other than going into more of a production mode to be able to cut 6 of them at a time. Now, like I said, the issue is if I cut this once, which was good, just screwed it down, I take that blue plastic off of there, getting that template back on the machine in a known location is a bit of a challenge. Again, just the same way as aligning that case in there. So to correct that, or to make it easier, I'm going to add some indexing pins to the board or to our template. So I'm going to go in and draw a circle, and I happen to have 3/8 cabinet dowels, wooden dowels. So I'm going to drill or cut a 3/8 hole. I'm going to put 2 of them in place. And it is, I always like to not make indexing holes symmetrical with one another. That way, when I go to put this on the machine, it is very obvious that which order it goes in, mainly because I may not have them centered within the object itself. So at this point, we'd just go in and toolpath for the circles the same way that we cut the outer boundary. Going to go on the inside, same depth. Only this time for the ramps, I'm not going to use smooth. I'm going to jump down for a spiral, which is makes a nice, very clean hole when you're making circles. So with that set, coming down, just give that a name of index, then calculate. And I would preview what that looks like. So now what those indexing holes allow me to do is, I don't do anything with them the first time this job is cut. After I remove the template from the machine and I want to go back and get this template put in the exact same place, I would then run this toolpath, this indexing toolpath, and cut those 2 holes into my spoil board or into my machine table. Then insert the dowels into those holes that I've drilled into the table, taking this template, placing it over top of those holes. They're going to line up and they're going to be exactly where I had them before I removed the table. And this is all from an absolute placement or distance from our 0, 0 origin. So just understanding where the 0, 0 is, and once you set 0 after drilling these index holes, you should not reset your XY 0 to a different location. So that's important to know. Another thing that you would want to do prior to cutting this is when you home the machine, C3, it comes back to 0, 0 lower left. It may be that I don't want to cut this right at my lower left table. I moved it up into the more into the surface of my table. So you could always move X and Y using the keypad or the M2, J2 commands to a new location. Before you re-zero it at that new location, write down what numbers are in the red position screen, the red DRO, of the X, Y values. If you record and write those numbers down, you will always be able to get back to that exact same place again. So what would happen is C3, home the machine, move the machine out to its location, say you just randomly move it out to 12.5, 12.5. Then you re-zero it at that location there with a Z2 command or 02 command. Then next week, 2 weeks from now, whenever it is, you want to get back to that same location. What you would do this time is C3 it, get it back to our table 0. Instead of just randomly moving it out to a position, you would accurately move it to that position with a actual movement command. So you would type in M2 or J2, 12.5, 12.5, which will move X and Y out to the location of 12.5, 12.5, and you will be able to re-zero it at that location. And everything will be exactly where we left it. So once the template is done and complete, we are ready to create the toolpaths for the actual job itself, the intended purpose of this, which is, again, to cut this slot in the top of the aluminum case. So there's a couple ways that you could think about doing it. One, you could save it to a new job or just stay within this project here. For this case, I'm going to stay right in this project. There is a couple things that need to do, and I should have corrected this before I made all of these copies, but that's okay. We will select them individually and look at a couple different ways of maybe changing and modifying what this is. So I do need to stretch that hole out just a little bit, and I believe it was a ½ inch. Yeah, you couldn't see me measuring. I just measured the actual hole that I cut for real. So I'm going to stretch this out to ½ inch. And to do that, we're going to go over to the set selected object size. And right now it is ½ inch high. I want it to be 0.5. I do not want to have this lower edge change, this cross here. I want it to stay where it is, and I want it to stretch in the upward direction. So to make that happen, we're going to click the lower left. In this case, we're going to go from lower left or lower right. It wouldn't matter since we're only changing the Y value. Selecting apply. So hopefully everybody understood what was going to happen when I did that. It's kind of went everywhere. It went way too big on the other side. So the magic keystroke Control-Z undoes what we just did. And I'm going to take a look at what happened. So it is this link X and Y was checked. So when I increased this by 2.5, moved it up to ½ inch, which I doubled the size in the Y, since the link X and Y was checked, the X also scaled to that same percentage. I only want it to grow in the Y direction, so I'm going to unlink the Y. And again, change the Y value to 0.5 and select apply. So there that is. So what I'm going to do is just go around and click all of them. I think in this case, we only have 5 of them, 6 of them, not that big of a deal. So I'm still leaving the job size and scale space opened up, and just selecting each one, typing a new value, then apply. If I had a lot of detail and a lot more function between all of these, I would have created, removed or deleted all of the features on the other 5, made all of the changes to just this one, and then did another array copy to copy all of those other vectors across the board. So with those complete, it's time to zero and figure out how to do this. So this is one method or one reason why you might want to save into 2 separate files. One is the height and the zeroing is going to be different, material thickness and such. So I'm going to do that now. And first go to File, Save As, and I'm going to call this one just temp for template. And I am working on the template side, kind of already done with that. I would have saved these files out, cut it just as we've seen in this video, cutting it out. Now going back up to File, Save As, and I'm going to call this case 6 times. I already have a case, which is that individual one. This time is, I have 6 of them. That'll help me remember what it is when I come back to it. Clicking Save. Now I'm working within the case file. So the template file is now completely separate, saved off all by itself. And anything I do here is not going to be affecting the template model. So the one thing I want to do is change the location of the Z0. So I'm going to go into Set Job Size and Dimension. And I want to 0 to the material surface. Now here is one that the job size 12 by 12. I'm still good with that across the board. The material thickness. Well, the actual case measures quite a bit thicker. It's like 1 inch high. It doesn't necessarily mean I have to make this 1 inch high because I'm really only cutting through 1/8 of an inch of the material here. So as long as I'm zero to the top of this surface, this flat surface here, and not this here, or I could zero off to the top side and use a start depth to get down here. What I did was zero the Z to the top face of the flat surface of the case. So material thickness isn't mattering and does not matter a whole lot in this case. But the material surface, we're going to Z0, that does matter. And we need to reference off of the top. So we'll say okay to this message. So what it's saying is I've changed the material thickness. I have toolpaths calculated. And since we've changed the material thickness, it affects what's already calculated there. I could say yes or no to this in this case because I'm not using the toolpaths that are in this list over here right now. In fact, I'm just going to delete them out of the list so I'm not confused by it and accidentally run that as the template or save those out to cut later, which could be bad based on the material or the location of the Z0 that I've just changed. So now it's setting up to create the toolpaths to cut through the slots. I'm just going through and selecting all that I want a toolpath. I'm going to close the options over here. Now I'm going to go in to create a profile toolpath. My total depth is going to be the 0.125. I believe it was 0.8, sorry. 0.8. I'm going to come in and change the cutter to a end mill. Now, if you remember from a couple weeks ago, we talked about dividing up and organizing the tool database here. So this end mill cutter right here is really the same cutter that I have set here, other than this 1/8 inch cutter is already set up for the parameters that I like to use for cutting aluminum. And that is, I'm making a 0.01 pass depth. The step over, in this case, it's a profile, it doesn't matter. The 1/8 inch cutter, normally aluminum you want to cut at a lower RPM. 1/8 inch cutters and small diameter cutters, you typically have to have those up a little higher. So I have the RPM set to 18,000 with a feed rate of 2 inches a second and also a plunge rate of also at 2 inches a second. Now, some of you might be questioning, like, wait, cutting aluminum, you're not going to be able to plunge into that aluminum that quickly. I'm not plunging. I'm not going to have this plunge straight down. We're going to be moving X and Y at the same time the Z is plunging down. So it's not a direct, or it will not be a direct plunge down into the material. If it was the case where I needed to plunge straight down into the material, I would not have the plunge rate be as high. I might come down to a 0.7 or a 1 for that. But in this case, since we're moving both and we're going to ramp in, setting both of those the same. Select that cutter, and it tells us that we have a total of 8 passes to get through this. I'm going to cut on the inside in a conventional pattern. Coming down, I'm going to add ramps, and we're just going to do it as a smooth ramp. Now, one thing to think about is what's going to happen to this chunk or the centerpiece as it falls out. In this case, I'm going to be okay with it because the bottom of the case is raised up and it'll just kind of fall to the bottom and fall through. I think that's shown in the video of this cutting, so we'll see what happens. So I'm going to do a smooth ramp and come down and just call that slot and calculate. come back over here to the preview. It just looked a little bigger than I expected it to look. So I just wanted to come back to the 2D view and make sure that this arrowed line was on the inside of these selected vectors there. So that's looking good. And at this point, we'll just preview what this is going to look like. Of course, it's not going to go all the way through because of the material. But we are able to see what's going to happen, and we can see that this piece here is what's going to be left, kind of left over. If we were cutting aluminum and this was, 1/8 inch thick aluminum or the 0.8 aluminum plate fastened down to the spoil board, we would have to pay attention to what's going to happen to this, because an 1/8 inch cutter, as we cut around and cut that loose, it's going to like bounce around and become a little, square ping pong ball inside of this cut, which will then eventually bounce in against our cutter and most likely break it. In this case, the inside of our actual product is hollow and it's raised up. So when we go to make the final pass, it's going to fall straight down and not interfere with the cutter and not be able to bounce around. So at this point, I would just go ahead and create this file, coming over to Save Toolpaths, checking the toolpath that I want to save, clicking Save, then Close. So we'll just jump over to the video and see what we did to hold that in place. And again, that was a slot. Our new file that I'm creating here is going to have 6 of them across here. And going to happen. So I must be out looking for something. There we go. Yeah, I was looking for screws to be able to hold this down. So kind of drops right down in there. The case has already some slotted holes cut in it. So I'm just using the holes that are already in the case to put a screw through to hold it in place. Give it a little wiggle check to make sure it's not going to go anywhere. And I should mention, I think everybody probably knows from now, if there's anybody new joining us for the first time today, please use the chat window, ask questions. If you have any issues or questions, ask them. I'm already seeing the thing that I want to change in what we're doing today. So when I cut this, I thought I cut this out with I did. I was seeing the 1/4 inch cutter in there. I was like, I really thought I cut this with the 1/8 inch cutter. So there it is. I'm changing the cutters. Yesterday was so long ago. So another thing that you'll notice that I tend to do is not use the Z0 plate too often. I'm not sure exactly how I measured this, if it's just strictly by eye or feeler gauge being paper. But we can see here is that lip that I drew out in the machine, or on the software. So we really need to come out and zero to the lower flat section of this. So what I'm doing here is using the fixed distance on the keypad and just moving it around and wiggling that back and forth until I feel a little bit of binding, or when I feel that bit catch on the material just a little bit. And once I feel that it is caught is when I went in and did a Z0. So you see at this point, this is cutting as it was when I first drew this. And I realized after I cut it the first time that I needed to increase the size of that slot and make it bigger. And you see that there's still that little bit of sliver material left there. It did end up cutting all the way through. So I did have to go back into the software and rerun it and adjust my thickness. But first, I think I pulled this off. We'll see what happens. Again, it was yesterday. Yeah, so why did I keep the dust collector cover off? Well, for your benefit. Normally, yes, I would have cut it with the cover on. I left it off so we could actually see in the video the cutter cutting the material, but the dust foot and the cover off, it makes it a bit of a challenge to see what's going on under there. But when I cut 4 of these, and I'll be cutting them again from our new file, I will certainly have the dust collector cover and brush on. Now you can see it's sitting back there, so I do have one. So I cleaned it up, modified the file just a little bit to cut a little bit deeper. And again, this was also still before I pulled it out and realized that I needed to make that slot a little bit wider. But we'll see how well this fixture and alignment actually works, because I do believe I pulled this back off of the table and actually pulled the case out. Hopefully the video doesn't actually go, I stopped it, I suppose. But what I did was I pulled it back off. I put it back on there to cut that table wider. So yeah, so here's a question that is seeing this piece down here, asking why the acrylic is under there. That's actually, it's not acrylic. It kind of looks like it. That's a sheet of 1/2-inch aluminum. And what I have done is that aluminum has 1/4-20 tapped holes in it. So I took it, drilled an array of holes every 2 inches on center, and I tapped them all. That allows me to quickly and easily remove the spoil board, put a new spoil board on, screw it down into those tapped holes, or remove the spoil board if I had a fixture or something that I wanted to put in place rather than the spoil board. Gives me mounting holes. So that is actually a piece of a 1/2-inch aluminum that was surfaced and trued up. So that is cutting that slot, and how to do that. I'm going to talk about one other thing that I've done here, and how I created this top cap that sits down over top of the aluminum case. Before I move on to that, anybody have any questions about the way we could index, replace this fixture back on the table to be able to recut it, or just any questions about this part of the process? All right, so the next part of this was creating another housing to fit, or cover to fit on top of the Raspberry Pi case, to be able to manage some of the electronics that I was adding in, which are a series of buttons, an on-off switch, and a light strip. So one thing that I realized, and when I was cutting the template for the the location template, it was a fairly snug fit as a measurement. I liked how tight it fit, so I'm just using it as a friction fit down over top of the case, which seems to hold in place fairly well. So there isn't any attachment or mechanical fasteners. It's just a friction-based cap. So I did go in, and the first time we cut, this is the second time I was out in the garage, what I was doing prior, just before I started here, was created the toolpaths for all of this feature here. So I'm going to just do a quick preview to show what this looks like. Looks like I've actually already previewed it, but again, just to make sure that I haven't changed anything. Reset and preview. All right, so we're just going to use this as a an example of what I've done. Going in and drawing some of this, we could do. And if you have any questions about it, certainly answer them. But we're just going to view and see the type of features and point out a couple things that I did here to create this. So the first time that I cut it, I only had one of them. So let me just start off with that and removing everything and just recalculating. So the first time I cut this, it was just one, just to make sure that it was going to be right. It was good. I did make some modifications. A couple of the modifications that I did was added a couple rectangles to get a 2-level pocketing here. So on the inside, I needed to have, after I cut it, I realized that LED strip, there wasn't any real way to hold that and fasten that in place. So I needed another internal type of pocketed out area to place that down in. I made the width of this lines here to be the width of the LED strip lighting that I placed in there. And that wasn't a profile cut. This is just a pocketing cut that I created. Just take a look at the vectors that are used to create these 3 slots and how this happened here. So we have the one area, which is the top side. So this is the vector that I used to create the pocket from here. There is another one right here that creates the inside, and then the bottom one out here that creates this pocket here. Now I got a little bit lazy in the way that I created the second layer. So now what that did was left these ribs, or these whatever objects you want to call them there, left them up still the full height of the material. I then created this rectangle out here that I used to create another pocket for. That wasn't the best option. I should have realized at the time of creating it, because I kind of made a very loud, vibrating type of sound when it came across that little sliver of material. In reality, what I probably should have done was come in and just did a profile cut, or drew a single line from this side to this side, just did a profile on the line, and probably would have cut that first to create the pocket in, and then came back out and did the other ones there. It worked. It got the job done. The quality of the cut still looked good, so that vibration didn't matter too much. And it is, again, on the inside, so it wouldn't have mattered really at all. The method that I used to hold this in place was a combination of screws and a carpet tape. The screws probably would have been enough by themselves, but I wanted enough of a hold down. So even though the screws are out here, would have held that material without any issue and kept it in place. What does and can happen is in the area where we're not able to get screws, I got it fairly well nested together, wouldn't have been able to really do any kind of hold down in this area here. So even though I have a screw out here holding it in place, there's nothing really holding this in place. So if the material is warped a little bit, not flat on the table, that little bit of gap could cause some vibration and in the material, which is going to radiate into the cutter, which is then going to turn into a not so smooth edge, and the edge is going to look kind of chattery. So that is the reason that I used the carpet tape. And I also wasn't quite certain about how thick the material was or where zero was going to be. I did not want to cut all the way through and into the carpet tape. Just kind of makes a mess of the cutter. This is HDPE, so a razor blade slices off fairly cleanly and easily. But I just didn't want to cut all the way through, because if you cut into that carpet tape, it makes a mess of the bit. It gums up and gets stuck to the bit, which ends up transferring and making a mess of the edge of your material. All of that cleans up. It doesn't really affect the quality of the cut so much, other than you end up spending a lot more time cleaning up. So when I created the cutting code for this in the files, I saved them out in 3 separate toolpaths. And the reason for 3 is I have 2 separate bits, 1/4 and 1/8. The 1/8 inch I use to go around and cut these circles, then the slot, and then the pocket here, or the profile for the on-off switch. So looking at the separate toolpaths, this is call it a groove, which is the little slot around here that is where the friction fit is coming from. The 2 pocketed toolpaths talked about. This is the cut toolpath. Then I have the 1/8 inch holes. The 1/8 inch bit came around here. I created a hold down screws. So 1, 2, 3, 4, 5 placement holes. This is like safe locations that I know that it's okay that the cutter is not going to interfere with that screw. And I know it's not, because I could see in the preview here that the cut is still on the outside or not interfering with that hole. So I saved that out, and then I have this toolpath here. So this final one is the same as this cut layer here. And notice I have a lot of past steps here. Not that I needed that many. The machine's certainly capable of cutting this in a single pass, if not 2 passes, especially in HDPE. It cuts very nicely. I wasn't so sure about my hold down method, and especially this wall of material that I have left is fairly thin, and we are kind of deep here. So I didn't want to have that under any kind of great load that is going to cause some vibration and push and pull against that edge, which is going to cause some a bad quality cut. So I did have quite a bit of passes here. So again, saving these out, 1, 2, 3, and 4. I saved, they'll uncheck this one here. We'll come back to that one. So that is the majority of the cut. Didn't cut all the way through. I'm up like 30 thousandths, 40 thousandths off of the table surface. After I cut that, I selected and cut the 1/8 inch bit. And of course, I did the hold down first. Then, since I wasn't sure exactly, and I wanted to cut almost all the way through, I wanted to leave the thinnest onion skin I could possibly leave. So this cut here, you see it's just as a single pass. Just double click on this cut path here to see that I'm cutting down to a 0.72. In this cut pass here, I am cutting down to 0.73. So I made it a little bit deeper. And what that allowed me to do is just save them all out. It didn't take, hardly any time at all to create that extra toolpath now. So I just sent them all out to the machine all at the same time, put them on the thumb drive, and went out to the garage and cut. So I saved that last final pass if after it was cut, I felt, grabbed a little, kind of pull test. If the material was fairly thin, it would have been fairly flexible here in the center. And I saw that I needed to cut it a little bit deeper. So that allowed me to then use that cut layer or that cut toolpath with a single layer and just only have that cut in there and allow me to set to cut a little bit deeper. Even though 10,000ths may not still have been enough, that's okay. It's still set up as one layer. So what I would have done is move the machine kind of off the material a little bit, move the Z down a negative value of what I think I want to take more off of, and zero the Z again. So like re-zero the Z just a little bit, down a little bit farther, use that same exact cut file again. And this time it will cut a little bit deeper. And I would keep going through that process until I felt that I was at the depth that I needed to go all the way through. So the 0.73, I didn't have to redo it again. So the 0.73 was enough to get it just enough to where the tip of a razor blade was able to pull these and slice them apart. So with all of that done, we got it cut out and have the finished product sitting here. So this was actually ending a little bit early with the presentation here today. It's called an endon system. So it's a notification box. So there is several of these stations that are placed around, say, at ShopBot. If the guy is out building a desktop and he needs some help by either an engineer or purchasing or sales, I got a question where he's going to be able to just kind of push the button. The button then notifies the correct person, and lights kind of flash, and it records a response time. So this is kind of a fun little project. You could do a little search for andon to see what that's all about. So there's existing product that's already out there like that, but they're fairly pricey. So coming up with our own method. And if you are curious about the the Raspberry Pi, if you're in there, inside of that black case, there's also it houses a small Arduino in there as well. So the Arduino is what's actually controlling the LED lights. So the resources out there for what cutters to use, there are. I can't remember. There's one of these sessions that we did. Find it on the our video page there. Talked a little bit about bit selections and kind of managing the tool database. CR OnsRoot is a location to go and find bit material. So let me just click through here and see if we have what training that may have been in. I wish I had a better memory. Well, anyway, going to CR OnsRoot and looking for chip load. and that will tell you what feed and speeds to use. And then the type of cutter, their catalog, their website isn't great, but if you don't have a catalog, send your ShopBot salesperson an email saying, hey, I'd like to have an on-road catalog. We'll ship one out to you. It is, the catalogs are much easier to use than the website. The catalog is designed in a way that they're in sections. So if you want, you're cutting wood, you open it up to the wood section, and all the bits that are used for wood are within that area there. Chip load sizes and charts are in the back of the catalog. So most catalogs these days are pointless because we have the internet, but this is one of those rare cases where the printed copy is still better than what you get online. All right, we'll call it a day. Everybody have a good day. Thank you for visiting with us.